All right, upper math or higher math. I just want to mention a couple of things, really. It won't take a whole lot of time. But the first thing is how upper levels of math is different from lower levels of math. And depending on who you ask where higher level math starts and lower levels of math end, you'll get very different answers. If you talk to Olivia, upper math starts in 3rd grade. She's in 2nd. So anyway, I just say that there's a little bit of a vague area about where exactly upper levels of math start. Really, in a general math world, upper levels of math would start somewhere about graduate level. Be real upper level. So anyway, so some generalities here, just really one main generality of the difference between the two. So, all right, lower math, I have it worded this way, is more rigid. More rigid. Students are taught generally a certain procedure and certain steps about how to do a procedure, and the teacher wants them to follow those steps. And there's a very good reason for that. I'm not trying to knock it, but they much more rigid. If you want to see the epitome of rigidness, maybe walk by when the elementary kids are chanting. If they're not worshiping Baal or Buddha, they're going through their times tables, and just got to memorize them. There's not any easy way around it. Just got to memorize them. Okay, so much more rigid, and then also here, typically the homework assignments involve a lot of repetition. There'll be 30 multiplication problems, and you're just crunching it out. Now, I would imagine that everybody here can remember that level of math. Okay. All right, so the early levels, elementary ages, and as you transition into the high school and start hitting algebra, algebra 2, geometry, pre-cal, some of the fun classes, things change a little bit. And definitely if you go on to college level math and other things, it changes a little bit. So, all right, so higher level math. I have lower level math is more rigid, typically lots of problems. The repetition there is designed to just kind of drive something into their memory. So higher level math is usually much less rigid. And that sounds funny maybe in a math setting. It's not that all of a sudden 2 plus 2 is 5. That only happens in... what's that national curriculum thing? Only in Common Core is 2 plus 2 equaling 5 allowable, as long as you can explain how you got there and it makes sense how you explain it. And I still would like to know how it makes sense to explain how you got 2 plus 2 equals 5, but whatever the reason. But anyway, I'm not talking about not rigid in that sense, but much less, it goes from much less of here's a problem and here's the 3 steps we're going to do to here's a problem. And you can attack it from multiple different angles. You can use geometry, you can use algebra on it, you can use trig, you can take derivatives and use calculus, or you could combine those. And it's not so much approaching something in a set procedure is following correct procedures and getting to the right answer. About 2 weeks ago, Juliana, my niece, we were doing a proof, if you remember trigonometric identities. All right, we're doing a proof from there. It was on the test, and I just gave them one trig identity to prove. And it was a summation, all right, double or half angle identities. All right. Anyway, she did this proof, and she got to the right answer. But wow, she went a really, really, really long way around. I mean, it was it hurt. And it was, I'm sorry, it wasn't identity, it wasn't a proof. She had to actually do the calculation, calculate the cosine of a certain angle, and you had to use those formulas. But she went a super, super long, complicated way and did everything correct and got to the right answer. I was shocked because you're introduced in all kinds of places to make math errors when you go the long way. And she got to the right answer. The rest of the class went the short way, and it really was a very short way if you went that way. But I didn't mock her off. She got to the right answer. All of the steps she did were legal, It might not be the way that I would have done it, but at her stage in life, I might have gone that way. So I had a professor that said, we can either approach this with the work boots and sledgehammer method, or we can try to do a little bit more elegant things that don't require so much as brutal labor. So, all right, so anyway, that's upper level math. You get away from the rigid. You've got to do it in these 3 steps. A little bit away from that. So, all right, another comment here about higher math. Understanding how something works becomes much more important. And again, this is maybe a difference of degrees. It's not that in lower levels of math we don't want them to understand. Just in upper levels, it becomes much more important of not just knowing the rules and of how you handle absolute values and inequalities. You guys remember inequalities?
Yes.
How you go about solving that thing. And when you drop the inequalities, what happens? At some point you just memorize it, but as you get into upper levels of math, you're wanting to see what's going on in the background, why it works. Okay? Do you guys ever remember doing stuff like that? Okay, so did you just do the rote memory? This is the steps, and don't confuse me with the knowledge behind it. Girls tend to be much more that way. It's like, give me the 4-step plan to solve this problem, and I don't care about why it works. Just give me the 4 steps. So, not all girls, but that is a little bit of a generality. So, okay, so much more understanding why something works as opposed to just rote memory. Another example. Just don't fall asleep here real quick. Complex numbers, generally written A plus BI. There's also a polar form of complex numbers. And there, the A is equal to the cosine of the angle. Not cosine. Maybe I should look this up. And I might have the B over A backwards. But that's how you convert from one to the other, and that doesn't mean a whole lot to you. But you can memorize that, or a much better way is to think about a right triangle, and here's the point AB, and we need this length and that angle. And you could solve it and find those and not have to just memorize that. So much more understanding how things go. Again, there are certain things you just have to memorize, but as you get into higher levels of math, it becomes much less computation and much more understanding things. Does that look familiar at all? We just talked about the polar form of complex numbers, and there's some beautiful things there. And if you had 3 or 4 days, we could build up to it and we could talk about it. Do you remember de Moivre's theorem? A little bit. There's some amazing patterns and things that you can't see with numbers until you look at them from that perspective. If you're kind of looking at Jacob from here, you can see his tie. If you look from the side, I don't know, you can see his arm and his ear, right? There are certain features you can see from the side. So looking at numbers as in the polar form, we can see some other features that are amazing. I think I wear that word out in my math class because every class this is going to be great. This is the best thing ever. Every one is the best ever. So higher math and lower math, that's kind of a general difference. You go from rigid, kind of rote memory, set procedures, lots of examples so you can just hammer things into your brain, to less rigid as far as the procedures, fewer problems, much more concentrated on the understanding. So, next thing. This is just a nuts and bolts thing from my class. And I stole this from another professor at Purdue that I really liked. For my homework procedures, what I do is I give them 2 nights for the assignment. Maybe I should back up and say I used to always struggle when I gave an assignment that was due the next day. The kids would go home and in some cases legitimately have questions, legitimate confusion. Other cases, they just came in and claimed that because they didn't do the homework, but tried to weed those out. But there was legitimate confusion, and if you've been in math classes, you probably remember sitting in class and the teacher does it on a board and say, wow, this is, a 3-year-old could do this. And they go home and all of a sudden it's very, very different on your page. Okay, so I used to struggle with that, and they come in with legitimately confused and say, all right, let's kind of rehash this, do some more examples, and then, okay, let's do the next day. And then we've got today's assignment that's got to be due sometime. So it was always this kind of rotating swirl of assignments that it was hard to nail down when they were due. So I switched to this 2 days. If I assign something Monday in my pre-cal class, it's due Wednesday. And I try to hold that hard and fast. And the theory is that Monday night they can try it at least to make sure they understand and come in and ask questions. And I set aside time for that in class. And then it's due on Wednesday. That way, if they walk into class Wednesday and say, I was so confused on the homework, I couldn't get anywhere, the one that's due that day, I don't feel quite as bad saying, I feel bad. Let me collect that paper from you, and then we can look at the problems. I find it much easier to hold fast to that schedule. Does that make sense? Anyway, that's helped me a ton, kind of nail it down. And every now and then the students do burn themselves and don't do it. But generally speaking, at least one or two of the kids, and there's only 4 there right now, at least a couple of them will do it on that first night, at least try to do it. And then they come in with with legitimate questions, and it helps everybody else. So anyway, that has helped me out tremendously, staying on schedule and keeping the assignments flowing. I still periodically will hit a snag and break from that, but I try to hold on that as much as I can. So, okay, so homework, that's helped me out a ton. The last thing is a little bit about my class routine. What I do in class. So this is pretty easy. First thing I do is start off with questions. If you think of the homework arrangement, there should typically be some questions. They, in theory, will have tried a new assignment the night before and finished up another assignment to turn in. So there should typically be some questions from that newer material. And I try to always start off with class taking those questions. Generally, I don't have to remember to do that because they're pestering me with questions. This current class, they'll even start before class starts. And I say, we got 2 minutes if you want to stop. I say, oh, no, let's go ahead. So we jump into it. But I always start with that, and I plan on it. I really don't mind taking 15 or 20 minutes if it's needed for legitimate questions. You always have to, you're dealing with people that were like you in school, or maybe like Jacob, that might just kind of float questions out there to see how long you can keep the teacher occupied. Sounds like history to us, doesn't it? Jacob said, no, I'm there because of a thirst and love of knowledge, and the questions. But anyway, you do have to be careful because students will try to take advantage sometimes, but you also want to allow for legitimate questions. And it's a math class, a higher level math class. They're going to be there. So anyway, I start out with that. If there's not questions at all, which is rare, typically I'll review, just kind of go back a couple lessons and review some things. Often I'll do both. Go back and review a little bit. All right, once that's done, the questions review time, then we look at the new material for the day. And it's not unusual for me to take 15 to 20 minutes reviewing, taking questions. And then it leaves me another 20 to 25 to cover the new material. So that works. Every now and then I run into a snag where I run out of time to finish the new lesson. But I try to leave a couple of slush days in my schedule so that if I hit a snag and fall behind, I'm not too far behind. I guess maybe I plan to fall behind so that if I fall behind, then I'm following my plan. It's okay then. So it's kind of like if I plan to be fat and I can just keep eating, so I'm following my plan. It's intentional. So please don't do that. All right, so that's my class routine. I don't think it's necessarily special or unique, but it works for me. The homework thing, I stole that, and I really like that. That helps a lot. So. All right, questions? Yes?
So I don't know if this would occur or not, but I know something that always happened in my math class where even didn't matter how much we reviewed, doesn't matter how much homework we did, it seemed like whenever test time came around, like it was just somehow in a different language. Like were not sometimes, or it was something that combined 3 or 4 lessons together. And what happens when you hit that kind of wall of I essentially have to kind of reteach and bring all this back together? Like, has that ever happened?
Yes,
Or-
it has. Not so much. Usually we've hit that wall before we hit the test.
Okay.
But if we did have a test that everybody just destroyed it, in a math class, most of the time you pretty much need to go back
Right.
and rehash it because the next chapter builds on that. So yeah, that happens. There's a balance there. I teach pre-cal, and there's a certain section of material that we're supposed to get through. And it wouldn't really be fair to say, one class got all the way through that, and another class only got halfway through it, to say, oh, look, they both got A's, and the one did legitimately more. So you got to cover the material, the whole material. But usually that's why, part of the reason why I plan on a couple of slush days in there to handle things like that, because it will happen. I mean, it was amazing to me. I finished school and started teaching, and then started back in school to get my master's in math. And all of a sudden, the perspective was very, very different for me. Now, I'd been a teacher for a while, and then I'm sitting there as a student, and the teacher's saying things that, oh, this is easy. And I'm going, wait, slow down. Go about half speed, and I can swallow that. And it just made me very much appreciate that students, they have to learn. You got to give their mind time to process things. We could take your entire lunch and just shove it down your throat in one bite, but it wouldn't taste very good. But if you give you time to chew it, it's much better. So, does that answer your question?
Yes.
Yeah, okay. Other questions? Not if we get to go. So, okay, upper math. If you become a math major, then we can talk longer maybe. So.